Participate, think, have an impact, and practice. Hello everyone, I'm Kay. In this lesson, we're going to cover a stylized wood grain tutorial. So what makes this wood grain stylized? Well, if you look at the colors, right, and then its shapes are, relatively speaking, all different from real wood. Compared to real wood grain, it's more simplified and more minimalistic. But it doesn't lack detail, so for wood grain like this, generally speaking, if you were to carve it, it would be pretty troublesome. But with SD, we can get it all done in one go. Whether you're doing some evaluations in a scene or mixing this wood grain with other images, it's all very convenient. Of course, it's the same when it comes to clothing related things. All right, so that's how things are for now. Many high end projects use this kind of software. That's the main reason, okay? Next, let's briefly introduce the production process for this. First, our approach is to have one, two, three, four, five, six layers of texture, and these 6 layers of texture are stacked together. It seems like the sixth one is in the wrong position. So there are 6 layers of this kind of curve. The textures are stacked together, and then each of these 6 curve textures is processed with a very crucial node. This is a very core technique for stylization called the quantumized grayscale node, which is used for stylizing processing. And then finally, some small details are added as finishing touches, and in the end, it's generated. We end up with a set of PBR based textures. As for stylized art, there's a pretty important aspect, which is the coloring. When it comes to coloring, we have a few methods. For example, just like when we paint, it's the same as laying down the base gray, right? Then you add details, build up the volume, and here too, you add more details. And finally, you establish the volume, add the AO, and in the end, you export it, right? That's also the whole logic and workflow we use for texturing. It's really just like when we paint, very much like our own process. For hand painting, for example, you first lay down a base layer, then paint the midtones, add the highlights, then paint the shadows, and finally add the details. That's pretty much the whole process, right? Now, let's take a look at this. This lesson's example includes some new elements, of course, and we'll introduce some new nodes. Compared to the fabric example we did before, the nodes here are a bit more complex. Let's take a look. First at the tile generator. Tile generator. This tool can also create things like something like this, which is similar to a little ball, just like what we have here. As for why we need to make these little balls, let me explain. When we look at this image, what we're really focusing on is its edges, right? We're looking at these small black and white boundaries. What we want is this kind of shape, specifically the shape inside it. So that's why we need to make it like this. How do we actually make something like this? For example, here we see 15 and 3, right? So in this case, it's done row by row, one row at a time. And then this pattern over here, that means the things we input need to be changed into this paraboy format. It's basically a little ball with some blurred edges. After that, the rest is really simple. That part is very straightforward. We just randomize the brightness, the size, and the position. Random of random. We take these random values, randomly rotate them a bit, and then there's something even more important, the blending mode. Here we're using a max native mode, so it can show the brightest spots for us. This is what the blending mode does. I won't go into too much detail about this. You can check it out yourselves. In my previous video, the second one, I did arrange everything in order, okay? As for the rest, for those things, we might need to adjust the size, right? Here, we need to set it to a bit larger, just a bit larger so it can connect together, like this, right? Then we can also turn on random offset, maybe just a little, and enable some of those other options. Let me take a look. And then there's also random brightness, right? Random lumens, random brightness. We also enabled something here called position offset. And here for the size, it's this thing here, a random value along the y-axis. Length and size along the y-axis. If we increase it a bit more here, if it's not big enough, if it's big enough, then we can get this kind of overlapping effect. So enable random y-axis size. Once that's enabled, we can generate in these black gaps some areas that are deeper, some that are lighter, giving it a more random feel. This gives it a more random feel, and as for the specific parameters, I believe everyone is definitely interested and wants to see them. So let's take a quick look at them. And over here, for example, we can fully enable the randomization on the y-axis or just enable it a bit, right? Then set the scale to 13, and the random scale setting doesn't really make a noticeable difference. Okay, and that's pretty much it. There's nothing else to it, really. The main thing is just that the size needs to be big enough. The size has to be big enough. And then just add a bit of randomization to the position, and that's basically it. There's hardly any difference beyond that. But for this image, we can make it a bit smaller, like 1023 or 1024. That way it'll be a little smaller. And then we can also, for example, we can shorten the y-axis here a bit, and we can turn on some offset, right? And maybe enable a few other things too. As for cluster rotation, well, just turn it on a little bit and that's enough. For random luminance, we can turn it up a bit higher to slightly increase the black and white contrast. See, when you press one down, another one pops up, right? When you press it down, something else gets pushed up. So here, let's switch this to a mix. For the lighting section, just adjust this area moderately, and that should be about right. Now, what's the difference between this tile generator and the other tile generator? Let's take a look at how these two tile generators are different. Basically, it doesn't handle our y-axis or any other randomization. Most of the parameters are almost the same, and here we've set the random rotation a bit higher, 0.06 here and 0.04 there. Also, the random brightness is the same. The goal is to create two patterns. They look pretty similar, but actually the shapes are a little different. They look almost the same, but actually this one is a bit more chaotic and random. The rotation value here is set higher by 0.02, while this one's a bit more regular. Okay, now here we apply a blur to both of these objects. Then we do a subtraction here. Subtract one from the other. You can see that we've extracted the fine edges. How did we extract this thing, everyone? Think about the logic behind it. First, we have a very clear image. And over here, we have a very blurry image. So after it's blurred, in the blurry image, the brightness of the black areas is higher than in the original image, right? The black areas in the original image are darker. So after subtracting the value from the original, isn't it easier for it to be preserved, right? That's why after we apply a little bit of blur, say a 2.4 blur, we can then use this to process the parts that were originally darker, subtracting from the original source. Look, here the value is zero point 0.7, and over here it's zero point 0.6, right? So zero point 0.7 minus zero point 0.6 gives us zero point 0.1, or about 0.01. We've managed to extract a very faint dark edge from it. Of course, pixels in other areas might also have some difference. There might be a little bit as well. This depends on the blur value you set. For example, if the blur value is small, the difference is smaller. If the blur value is larger, then more details are retained. In short, this is one way to extract the edges of our texture. Once you've extracted them, you can use the level adjustment to crank up the contrast really high. That way, the mesh pattern is brought out, and the same principle applies below. And then this box count is also reduced to 1. So this is our basic material. Let's set this aside for now, and next, here's what we're going to do. What are we going to do? We're going to make something called directional noise, because noise is something we've encountered a lot before, like our cloud, right? Including our BMW and also our regular noise. For example, Perlin noise, grunge. Perlin noise is one of the ones we've commonly used before. Now, we have a new type of noise, which is directional noise. This noise, visually, it gives us more of a sense of direction. And here you can also adjust its direction however you want, right? Okay, so here we're using directional noise. After directional noise, let's add another one. Gaussian noise. This is Gaussian noise, which is pretty commonly used. Its main feature is that compared to our poly noise, its randomness is even greater. As for this poly noise, let me zoom out a bit. With poly noise, you can see that the black and white contrast is pretty strong, but from a higher viewpoint, it's not as pronounced. Also, the transitions between black and white are tighter than what we see in some of them, right? This one feels like a blob, while this one feels like it's made up of separate pieces, right? That's the difference between these two types of noise. So what do these kinds of noise generally look like if you guys are working on something graphical like this? You really need to have a sense of the numbers in your mind because once you do, then over here you can transform. When it comes to transform, what we're really doing is rotating the image a little bit. How do we do that? You can take a look. For example, if we rotate it like this, right? Or hold down the control key. Yeah, let it flip. Either way works. And if you want a really precise value, if you want to make an adjustment, you can do it here under what's called edit metric values. Over here, it's 0. And here, the original value is 11,001, right? The new value is 0, negative 110. So by adjusting this matrix, we can achieve an image flip effect. Of course, if you hold down the control key, right? Hold down control and drag it like this, you can also see the values here. See? This part changes. Then, for example, -1, x2, and then hold down the control key and drag. You can see that these values are actually all changing, and that's exactly what we want. Then, if we hold down the Alt key and move it, actually, it's the edge here. What we're moving is also a value here. So if we want to change it to 00 now, what does 00 mean? It means we hold down the control key, drag this side all the way to 0, drag it out really far to 0, and set this side to 0 as well, right? It'll stretch out really far. And then over here, for Y1, if we want to change it to 1, we hold down the Alt key and set it to 1. We just drag it over at an angle. It's still pretty flashy. When we set Y to 1, it's close to 1, which basically gives us this kind of slanted sliding effect. And then here, if we set it to 0, it stretches out a lot. All right, so for Y2, right now, we're talking about this thing up here. Which one is Y2? Yeah, 2. Yeah, one. X2, X. If we set it to -1, it's like we're sliding the slant over to this spot again, right? And then for Y2, we hold down the control key, and of course, this thing over here. Basically, it stretches the image out really long and then does a slant transformation. This thing isn't very clear to me. It's not very intuitive. Anyway, if you want to flip it based on this graph, you need to rotate it. Just rotate it along this side, and we can do that by changing the matrix, of course, as we it's either a positive one or a negative one, just an integer. This kind of change creates a different texture. Actually, there's an even simpler way, which is to just modify it directly. The setters here can also make it a little different. It feels like if you swap it in, it actually works too. There's really not much difference, right? Then here we're going to do a warp. I won't go into detail about what warp is. It's basically like we're twisting this thing a bit. Then the thing below also gets warped. So now it's like we have two of these warps. That's the material, and over here is our directional noise. Then we do a level adjustment, and here we use this long uniform blur grayscale. We don't need to introduce this too much, it's just a dump blur. We've used this a lot earlier, and the purpose of using it here is mainly the purpose of using it here is that you can see our direction is downward. The main reason for this downward direction is that we want the image to have an irregular downward blur, an irregular effect, a downward blur. This way, you get a sense of grayscale, and that's how you can pull it out, right? Right. Okay. Then over here, we use another directional warp, still the same thing as before. It's just that we changed its matrix quite a bit, basically transforming it. You see the box, right? It's like we twisted it too much and shrunk it down. Shrunk it into a vertical column, shrunk it down, a vertical column, and then here there's another directional warp and line uniform directional warp. The difference is that it doesn't create too much of a blur effect. It's sharper overall, and it's basically like creating a new material, right? You can see that we now have several materials. Let me walk you through them so you don't get confused. So right now we have our line uniformer, the first one, the second one, and then after the line uniformer blur, there's a directional one. That's 3, right? Then over here, we use a transform to shrink it down. After that, there's another one. And then this warp is combined with our Gaussian for a warp, which creates the fourth one. So to sum up, we have a total of 6. Where do we find these 6? First, the first one is after we did the English style turbulence, then a direction warp, and then we shifted it over a bit. That's the first one. Then the second one is our thin strip, the thin strip. After we flattened it, we shifted it down to the left. That's the second one. That's the second one. What's the third one? The third one is the original English style turbulence that comes out. After that, there's an original one. What's the fourth one? The fourth one is when we take this one after performing a warp and then flattening it, first flattening, then warping, it forms another one. So that's the relationship between the fourth and the second one. It's just that their positions are different. Okay, the sixth one. This one needs to be a bit brighter, so it should be a level adjustment. We extract our thick branches from this. This is the fifth one. And then what is our sixth one? The sixth one is where we don't flatten it, we just use form blur. After that, we add the original direction warp. The only difference between it and the first one is the brightness is different. This one didn't even add a level. Also, the first one has a displacement to the lower right. In short, it's just about doing some transformations, especially flipping and transforming these two images back and forth, making some adjustments, changing the levels, and then basically forcing out six different elements. That's all you need to understand. Okay, and then we also noticed something else, which is about the first one, right? This thing in our first row, this thing, actually, it was only used once, only when it was 5 and 3. So what is 5? 5 is when the larger core stems are kept, and 3 is also when the larger core stems are kept. So these two things are used as large indentations for core stems. The only difference is that one is more obvious, and then the other one is shifted a bit to the upper left, and the remaining four are all made up of smaller elements, smaller things. This will add some effects, like here where it's squashed, right? This side is squashed, direction warp. Here we do a bit of squashing, and after squashing, we apply a warp. There's one where after squashing, there's a displacement, there's another one, then one without squashing, and then another one. And what about the last one? The last one is squashed, then warped, but without displacement, and instead it gets something brighter. There's a 4. Okay, I'm not sure if everyone can follow along like this. Is it clear enough? Can you see it clearly? I hope everyone can see it clearly, and anyway, just open this node. That's it. If this file isn't very clear, you can download it yourselves later. Go to my public account and download it to take a look yourself, okay? And over here, what is this? This is a cloud. Noise, cloud noise. We performed two transforms, and then here we applied a level to the Gaussian blur. What are we doing here? Here, we're adding an excitation here. First, we combined these three sets of noise into one. Right, we mixed them into a single noise. We can change it by adjusting its parameters, but it doesn't really make much difference. And here, the direction is set by itself. It assigns its own direction. So the white part will slide down more. And the black part slides less, just a bit. It gives you this feeling of sliding down. And then over here, we add another one, the direction we used earlier. So what's the purpose of this step? The purpose of this step is the purpose is to create a base texture with a stronger lightning effect. Because if we only use this wood grain, it won't work, right? It's just like in my previous DS Mini project. The purpose of creating the base texture there was the same. It needs to have this kind of feeling, kind of like wooden grooves, right? So what we use is directional noise warp. Just one noise is enough to create the small wooden grooves, but we want the grooves to appear on something that looks like wood grain. So what does wood grain look like? Isn't it just something like this, right? So here we use one noise and add a directional warp to simulate it. This kind of effect, this thing, it's definitely not realistic. Definitely not realistic. But from our mid-level perspective, it makes sense logically. Okay, so here, let's add a levels node to lower the brightness a bit, since it's going to be used as a background. It can't be too bright, right? And then over here, it's just subtract, 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 subtract. This side is all about subtracting. These three things, 1, 2, 3, are all related. They're all subtracted. So remember, these three things we're subtracting. What are they? They're details, areas that need to be recessed. 1, 2, 3 are subtracted, and then what's the fourth? The fourth is also a detail, the fourth one. But here we switch to screen. What does screen mean? I won't explain it again. I already talked about it earlier. So you need to understand why the first two, the 1 and 2, need to be subtracted, right? The purpose of subtracting 1 and 2 here is because of the two details. One pattern is higher. Tiling means one is a bit higher and one is a bit lower. First subtract them, and then there's this third thing. Isn't it a detail pattern? It's actually our main pattern. The main pattern is made up of, from the very beginning. Here, it's like trimming the main pattern a bit. That is, some of our details are indented downward, and some parts of the main pattern are also indented downward. And then what's left is just added in. As for the rest, so for this part, right, the screen isn't added here. These are some details that are raised upward because when we make things, we also have to stick to the principle of working from the bottom up. So we trim first and then add, press first and then highlight, okay? Here we've added the screen and then over here there's another. The screen is an even stronger fine detail, and this last one is the most pronounced detail. Now let's break it down and practice a bit. This is the main structure. Then this is a small detail, and this is a medium detail, right? And this is a small recessed detail, and this one is a medium detail. Recessed small detail, recessed large detail, recessed. So you can see our goal with 3 additions and 3 subtractions is to have 3. These are the 3 different tilings that protrude upward, and then the 3 different tilings that are recessed downward. It's that simple. Okay, and over here, let's connect it with our this 6. And finally, we add this 6, 4, 5, 6. Okay, that's it. Now, here we come to another key point, which is making a technique that's used a lot in stylization called slop blur. Slop blur. I talked about it in my previous courses, but here I'll go over it again for everyone. I know most of you just watch this part and skip the earlier stuff. You all tend to be picky and only want to learn what you're interested in, so I'll explain it again for you, okay? Now, what does slop blur mean? Slop blur actually, you can basically think of it as a black and white image here. And when you turn the intensity up high, right? The white areas will start to spread outward. The white part is what you input as the slope. The white areas in this image will affect the areas of your inner image, pushing outward. It spikes out. If you set it to a negative value, then the white areas become your slope. In this case, the second image will contract inward. Just think of it that way. If it's a grayscale image, but if it's not a grayscale image, if it's one with contrast, if the contrast is strong, we just pull it straight to white. But if the contrast isn't strong, in the image, you can see there's no gradient from gray to white, so it's hard to create that kind of blur. That's why the slope map for slope blur has to be a grayscale image. It can't be a completely black or completely white image, right? As long as you get this point, that's enough. So pure colors, pure black or pure white, actually don't really affect slope blur much. The impact is minimal. It's mainly the gray areas that have an effect. And then using the slope blur grayscale here, it's like what we just talked about, using slope blur on itself. Here we set a value of negative 0.02. So that means the white areas will contract, right? The white area we've specified is basically here, right? And in the original image, the white area is also here. So it will contract on its own, and that's how this effect is created. This makes things pretty clear, doesn't it? It's because of this kind of self-shrinking effect that gets created. And after this self-shrinking effect, it will compress some of the gray areas. See these gray areas? They're pressed pretty sharply, right? So in this way, it will create some rather sharp patterns, which also look really nice because this grayish look feels soft. Everything feels kind of soft and gray, right? So if you give it a negative stop blur, it can preserve that. Some of these softer, grayer areas can also generate some rather sharp and harder spots, like right here. So this node is really the soul of the whole randomness creation process. See this earthy gray, this softness. Some parts are hard, some are soft, and the lines vary from thick to thin. That's what makes it look so good. So if you want to create this kind of random feel, or if you want this kind of effect, just remember this formula. Basically, when you apply it to itself, it expands outward, and when you use negative values, it pulls inward. Of course, if you look at positive values, right? When we use positive values, it expands outward. But here, I obviously don't want it to expand outward because for the size of this image in front, I want the grain and these details to stay fine, right? It's wood after all, so the grain should be finer. So here, we give it a negative value, a reverse direction. After reversing it, what I'm aiming for is to have more of the white areas concentrated on its surface. And the black areas are concentrated in its shadowed parts, right? Because right now our wood grain is relatively dark. So this is definitely reversed, right? We want the grain to be darker, like this. All right, okay. So what is this next note about? Something new again. First, let's define web. Changing from black to white into something that goes from red to green, what's the use of that? Let me briefly explain it to everyone. This involves something new for us. The node is called vector warp, which is our vector blur, vector warp, vector deformation, pretty much the same thing. That's what it means. So what does vector deformation actually do? Basically, it only uses the red and green channels of our image. So what does red represent? Here, I've created a new node called the sRGBR node. It's black for G, black for B, and all the red, green, and blue channels are black. Alpha is a okay. Now, if I increase the red value, you can see it shifts to the left side, translation to the left. If I lower it, it shifts to the right, translation. If we increase the B value, it will move diagonally upward. It moves upward, right? There's a displacement. If, wait, I misspoke. If the green value increases, then it'll move even more in the diagonal, upward, and upward directions. There will be a greater displacement. If our rate value is even higher, it will create a translation. So as you can see, this vector node, it actually uses the red and green channels of an image to control the overall offset of the image. A kind of work. If you turn on the blue channel, see if you increase the blue value, it doesn't have any effect. If you turn off the alpha, it also doesn't really have much effect. So it only uses our red and green channels. We can look at these values. Our red channel has this much, green channel this much, and the blue channel has none, right? So over here, if you change the image to a red green one using a gradient to dye it from red to green, then it will create some offset. Okay. So what exactly is this offsetting? It's actually offsetting a node called anisotropic. We won't go into too much detail about this. We're just using it for texture. And finally, if you add a Richter walk, right, the Richter walk will introduce some random offsets. These random offsets basically shift the image into what we have now. It's kind of hard to describe exactly what it is, so let's just wait and see. It actually looks pretty nice like this. This thing mainly adds some contrast, right? It also adds some randomness. This is a way to increase both contrast and randomness. So I draw it like this, and then here there's a new node called FXFXA. What does AA mean? AA stands for anti-aliasing. This is called anti-aliasing, which is a filter for smoothing jagged edges. Why do we use this? Let me show you all an example. You can see that first we have a small ball, right? Then two small balls, we set a level. Then as we continue, let's imagine doing some tessellation. You can see that when the image is very small, this is only 256. When the image is very small, you can look at the edges, right? It's just a block of white and gray, isn't it? When you look at it from a distance, it appears jagged. But if you add an FXAA, it will look much better than before. It's a lot better than others. At least the edges look smoother when we view it like this. If you look at it this way, the jaggedness is really obvious. So you can treat it as an anti-aliasing effect for graphics. Of course, you can also duplicate it and apply anti-aliasing again, right? There will still be a bit of a difference. But the difference isn't that big anymore. The change is already minimal because it'll make the jagged edges even smoother. But the way I used to handle it was to add something like HQ at the end, right? If we add a little bit of HQ, just a bit, it actually becomes smooth already. So we can use something like F6AA first to deal with the jagged edges. After smoothing it out, add an HQ blur to make it even smoother. That way it looks more rounded. This is one way we use FX. And then there's one below. The core node we just mentioned is called quantize. Quantize? Quan. I don't really understand what quantization means either. Anyway, this node is also very simple, okay? Don't overthink this node. After we add this node, it looks like this. Let's look at a few parameters. What does step 2 mean? It means taking our original input image. It's better to start with fewer. It looks nicer. The original input image is split into 2 colors, 3 splits it into 3 colors, 4 splits it into 4 colors, 5 splits it into 5 colors, and 6 splits it into 6 colors. Okay, if you set it really high, for example, if you set it to 999, then there's not much difference from your original image. Basically, it just processes our original image with a kind of resampling. After resampling, it then does something kind of like this, like distributing black, white, and gray. Basically, it takes our image, for instance, splitting 256 colors or brightness levels into 16 levels is what that means. Second is offset, which basically means we can add randomness. Alright, so not only can we separate the colors, but we can also apply a random offset. The third one is a more flexible option called slope. So after we apply the random offset, we can also add some blur. So after adding randomness and then applying blur, we can compare it with the original image. If you set the blur really high, right? At least with these two images, they look pretty similar. but that's only for NC. If you switch to a different image, it might not be the same. For example, if you switch to a different noise like Perlin or use Perlin noise, because its image, the characteristics are pretty similar. For example, after you increase the blur here, it starts to look more like your original image, right? Because all your pixels have been smoothed out, they've all been softened. But if your original image isn't a blurry one, then obviously once you increase the blur, you can't restore it. This can't be undone. So don't overthink it. Just leave it as is. As long as you can blur this area, that's good enough. Types of blur. There's linear blur and there's smooth blur. Linear blur, in this case, there's a linear change here, basically a 0 to 1 linear transition. Change to smooth blur. If it's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, it's more of an S-shaped transition, which looks smoother. There's also a third type of blur, which is curve input. We can input this S into a curve node like this. So what's the use of this? It lets us decide the direction of the blur. For example, if we only want the end part to be blurred and the beginning part to stay sharp.